Okay, let's begin. Hi, I'm Korean Peer Shepherd. Today I will discuss data types. Of course, those familiar with this topic won't have any issues, but for those who are not familiar with computer architecture, data types can be quite a difficult concept. If you do not understand the data type precisely, you might face challenges in calculation involving decimals or expressing characters. Therefore, in this video, I will help address these difficulties. Before starting with data types, in the last session, I explained bits, which are represented using 0 and 1. Next is bytes, which are group of bits. Group of bits. 1 byte consists of 8 bits. First, remember the unit, byte. 8 bits equal 1 byte and 1 byte equal 8 bits. Please keep this in mind, as I will be mentioning it frequently during the data types discussion. Okay, and next page. Data types are broadly classified into 3 categories: character, integer, and floating point. Within these categories, there are further subtypes depending on the range of values that can be represented. The name of the data types are as follows: character data, CHAR, integer data, short integer data, INT, single precision floating point data, float, 4 bytes, double precision floating point data, double. Now, do you see the table below? In the table, I have highlighted the boxes. If you look closely, you can see how many boxes there are wide. Right? Yes. As I mentioned earlier, these are the byte count. You can see that a character is 1 byte, short is 2 bytes, integer is 4, single precision floating point 4 bytes, double precision floating point 8 bytes. Let's pick one of the data types and discuss it in detail. First, the integer type. Integer type includes this short and integer int. Short 2 bytes, integer 4 bytes. A short is 2 bytes, and a few minutes ago I mentioned that 1 byte is how many bits? Yes, that's correct, 8 bits. So 2 bytes would be 16 bits. For those familiar with MLSEC PLC, you might refer to size of this data type as 1 word. These are just differences in terminology, and none are incorrect. The integer type can represent positive integers 1, 2, 3, 4, 5, 6, and negative integer -1, -2, -3, -4, -5, and 0. Since it is an integer type, it cannot represent decimal or characters. the integer type can be used with or without a sign. When a sign presented, it can represent both negative and positive values, and without a sign, unsigned, it represented values from 0 to positive. 0 to positive, negative and positive value. Because of this change in representation, the range that can be expressed also change. For example, signed shows negative 32768 plus positive 32767. Unsigned shows 0 to 65535. So, how do we represent negative and positive numbers? There is a representation called two's complement. This method can be used as follows. Invert all the bits of a positive number and add 1 to it to get the negative value. Now, let's see why this method was developed. I will use positive 3 and negative 3 as an example. Using to complement, positive 3 is converted into negative 3. Here is. Then I add positive 3. Adding the first bit results in a carry plus 1 and carry. And after all bits are added, the final result is 0. 1. Okay. 1 1 0 1 carry. 1 1 0 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 carry. With the carry being stored in the carry flag. With this, you should clearly understand the reason and method for converting positive numbers to negative numbers using to complement. Next, floating point type or real number type. The floating point type is a data type capable of representing decimal numbers. As you can see, it has a much wider range compared to get integer type. Float is 4 bytes and double is 8 bytes, but in MATLAB PLC they are classified as single precision, and double precision. Also, this is an explanation of the floating point type based on single precision. I will create video later to explain it in detail. So, why are the integer and floating point type separated? Let's take a look at their difference. Okay, I open PH program. Give me a second. Okay. M0. Division D0, D1, and D5. M1A first contact. E division D10, D12, D15. Here are D0, D1, and D5, D10, D12, D15. The difference is that the upper group represents integer division operations, while the lower group represents floating point division operation. Let's go to the simulator. Okay. Let's input value of 1, 2, and in D10, single precision floating point 1, and D12. D12 data type is a single precision floating point. Value is 2 set. Let's input values of 1 and 2 for each and perform the calculation. Before executing, let's think about it. What will be the difference between the two results? Naturally, both should yield a result of 0.5. But what actually happens? Let's execute it. Floating point division 0.5. Integer division is 0. Interestingly, the integer operation values 0, while the floating point operation value 0.5. The calculation result was 0.5 since the integer type only represents whole numbers such as 1, 2, 3, and 4. It cannot represent decimal values. Therefore, if you need to perform calculation involving decimal points, you must convert the data type to a floating point type and then perform the operation. Is right?